Ready to learn some more skills in Easel? Then stick around because that's what we're doing in this episode. Hey everyone, and welcome to another episode of James Dean Designs. If you're not already subscribed, hit the link in the corner to get all the latest videos. Now a few weeks ago I put out a video for a beginner's guide to Easel, and we went through some of the tools and features, how to set up a project and output a very basic sign to our CNC machines. Now today's episode is a step on from that. We're still sticking with Easel, and we're going to be looking at some other features and tools within that software in order to do another project. Also some issues that may arise when you're doing your own projects and ways to work around them. Now just to recap, we are looking at Easel, not Easel Pro. Easel is the free version, Pro is the paid for version with some extra features. If you've got any queries around software, check out the link in the corner to the recent software video I did, which clears up a lot of the questions around that. Now for today's project, I try to do things that I either know people can sell on, personalise for families and friends, or something that can be a bit fun. So what we're going to do today is create a handheld game, more specifically a handheld maze that we can play about with and have a bit of fun. So let's get started. So we're beginning today's episode by looking at the setup rather than jumping straight into the software, and there's a reason for this. Some of this is going to define decisions we're about to make within Easel. Now the first thing that I will flag is obviously we're using the 3018 Pro for today's episode, so that's going to dictate the feeds and speeds we'll be setting later on. The next thing I should point out is that towards the back here we've got this green paint, and the wood's quite rough here and it also slopes off, so kind of this isn't really good for us to work with. If I bring a square in as well and set it against this bottom edge, we can see just how much this right hand side is off. So again, it's not very square for us to work with. So what we're going to be doing today is really focusing on the middle of this piece of wood as our centerpiece to be able to make something today. Now the next thing I'll point out is this whole piece of material is held down with blue tape and CA glue. An alternative method is using clamps around the outside. Now as I just mentioned, we'll be focusing on cutting out a middle piece from this wood. If you're using clamps and you cut out a middle piece, as you get towards the later passes, you run the risk of that middle piece coming loose. We're going to look at something called tabs in Easel, which is a way to stop that coming loose as you're cutting. Now because we're just using the middle piece of this, I've measured it out and it's approximately 200mm wide by 140mm deep. The thickness of the material itself, this piece of oak, is just over 20mm. Now we will be doing multiple passes in today's episode, so if you haven't got one already, build a Z probe, buy a Z probe, and definitely check out the link in the corner in how to do that and get everything set up correctly. Now let's move over to Easel and start to learn some new features there.
So I mentioned about the previous beginner's guide episode. Now any features that I covered in detail in that video I will skim over in this video to save bogging it down with things that we've already covered. The purpose of this video is to look at some new features that we haven't previously played about with. So we're going to start by clicking New Project. Then the first thing we'll want to do is set the size of the piece of wood that we took a look at. So we're going to come up here and click on width and then change that to 200mm wide by 140mm. Now the depth of the piece of wood is 20.5mm. I'm going to set this to 20.8. I always like to set it a little bit deeper to guarantee that whenever we do a full cut it goes through to the bottom. So 20.8mm. Then we'll come back over to our design area. Now we can see the visualization has updated that automatically. So now I pointed out on the piece of oak that some of the edges were a bit rough or not quite square, and this is also going to be a handheld piece, so we want a nice clean edge all around it. So the first thing we're going to do is draw a border within this that will be cut out, and that essentially will then define our work area going forward. So I'm going to begin by coming up to the square tool, inserting that, and I want to get it close to the edge but not too close so there's a little bit of a border, and then just stretch it out to fill that space so it's fairly even gap all the way around. So once I've done that, that is fairly even now. Now we can see on the visualization that this is doing this as a pocket, so it's taking out all of the middle. We only want this to be a profile cut, which is just a singular cut going around the outside, leaving the middle alone. So we're going to come over to the cut tab, and we're going to set this straight away to the maximum depth. So we'll drag that down to 20.8. We'll see that's just taken all the middle out there. But the difference is we want to take this from a pocket cut to a path cut, and I'm going to do this on the path line itself. So now if I move this visualization around, we can see that the cut is going all the way through, but just doing it as a singular outline path. Now as we went to the full depth on this, you will have noticed this extra menu come up down the bottom, and these yellow marks appeared on the design area. These are tabs. They are essentially for keeping your material secure when you cut through it. Now because we're holding the material down with glue and tape today across the middle, it's less relevant. But if you're doing this and you're just using something like clamps, what would essentially happen is as you're machining this outer border out, once it gets to the last cut, this middle piece will start to become loose. It may ruin your job, it may break, it may even damage the spindle itself if there is too much force. So what the tabs do, they're little pieces of material left in that help keep that piece of material in the center in place and secured. You can adjust some of these. You can adjust the length, the depth of them, and the amount of them. If it's something simple like a square or a rectangle, 4 or 6 may do, and as we adjust this we'll see that it updates live going around the cut-in profile. Now as I've already mentioned, we have secured everything down with blue tape and glue today, so this is not needed. So I'm going to turn these off. The other thing as well, as this is a handheld maze, I want to just soften up these corners. I don't want it to be too blunt, so I'm going to come back to shape and just put a 5mm radius on those corners. And as you see, it just rounds them off nicely. Now let's move on to creating the maze. Now you could use the shapes and tools that are already inbuilt in here to start to draw out your maze, using lots of different rectangles placed all over and just in different configurations, rotating them around. I'm doing this very quickly, but you can start to see the idea where you're creating this maze run within the material itself. Now fortunately, Easel has an inbuilt maze generator. So I'm going to delete these out of the way, and then we're going to come over to the apps library. As I've mentioned previously, there are lots of useful tools in here that are like plugins to the piece of software. Do take a look at them because yeah, you can really have some fun with the bits in here. We're going to come back up and focus on the maze generator itself. Now it gives us an idea of what's going on and some instructions for these settings down here. Now unfortunately they are all in inches, so if you're used to working in millimeters, you will have to do some conversions. Now the first thing it says is the wall thickness should be 1.5 times the width of your marble. In our case we're going to be using a 3mm ball bearing. So 3mm converted into inches and then multiplied by 1.5, I believe is about 0.207 inches. So I'm going to type that in, enter that. Now when we get down to the columns and the rows, you will see here that this is essentially built up of a grid. There's lots of columns and there's lots of rows, and certain places are just converted to grey in order to make that the path of the maze. So in essence this is how complicated you want the maze to be. So if we drag these right up and drag this up one in comparison, you will see the maze gets very complex. Now I don't want it to be too complex, so I'm going to bring this back down to about 20 and 20 for the rows as well. And now we've got a bit of a maze going on, but it's not going to be too complicated for the end user. The final option, called the seed, now this is basically the generation of the map itself and how difficult it is to get from the start to finish. As you slide this up and down, it will generate different orders of the way this maze appears. Now if we look, we've got the start and the stop included, which is this top right and the bottom left. It doesn't matter which one is the start and stop at the end of the day, it's just this is the entry point and the exit point for the maze. And as we slide this about, you'll see it generates different layouts. Some will be more complex than others, some will be fairly easy. So I'll try and find an easy one just to explain it. Perfect. Now as you can see, the entrance to the maze literally comes straight down, across, up and over, and you're back out. So from a user's point of view, that is going to be really simple to complete this task. Now I'm looking for something a little bit more complex than that, so I'm just going to slide this up and down until I find a configuration that I'm happy with. There we are. So it's going to take a bit of work for the user to get from start to finish. So they're going to have to come all the way down, double up back over this section, all the way over to the right and then down, back across, up and over, and work their way to the finish. So it is going to be a bit of a challenge. We will be adding some more obstacles on the way and I'll talk about that shortly, but for now I'm going to click import. Now it's imported at the size that it is based on the ratio of the ball bearing and that wall thickness that we set. Now I just mentioned I'm going to be adding some more obstacles into this maze, so I want to leave these channels as wide as possible rather than the set ratio from the maze itself. So I'm going to enlarge this up slightly, but I also want to leave a border around this edge itself because I don't want to get in too close to the edge of the profile cut, otherwise it may mean that some of the edges break off as we start to machine it. So I'm just going to try and get these little tabs on the top right and the bottom left close, but not quite touching that outer profile. And then a similar width on this left hand side, so we'll slide it over a little bit. Now if we look on the visualization, we can see the start and the end point, but they're not open in order for us to slide that ball bearing in or for it to fall out on the finish. So what we're going to do is I'll zoom in on the visualization slightly so you can see this update, and we're also going to zoom in on the design area. So if I zoom in and move this about. Now what we want to do is extend these little feet out into this profile cut area. So we're going to click on the maze and then we're going to click edit points. And you'll see lots of dots appear for all the points or nodes that you can edit on this shape. So you just literally have to click on them and you can drag them and manipulate them as you need to. I'll undo that for now. We're going to try and drag these little 2 feet into this black area that's being cut out. So we're just going to click on one, drag it in slightly, and click on the other one and drag that down slightly. Now you'll start to see the red lines appear around that arrow. That just means that you're keeping everything at a 90-degree angle in relation to something around it. So we know that is all still parallel and square in the way it was originally. Now if we come over to the visualization, we can see this has also been updated, and the entrance or exit is now there. Now there's a bit of tab left over and there's a bit of a conflict going on in the cut. I'll come back to this shortly, but first we're going to go up to that top right and edit that one as well. So I will move the visualization around so you can see this as well, and we'll drag that point and go up a little bit, and we'll drag the one next to it and go up as well. And again we can see it is now cutting into that outer profile. However, this little tab that we have going on here where it's not quite cutting all the way through, this is a bit of a conflict within Easel. Now the cutting order within Easel is defined by the order that you draw things in. So for example, because we drew the outer border first, it thinks that what needs to be cut first. And then when we drew the maze on top, that is a different depth, so it thinks there's a bit of a conflict going on. Now for safety, it's taken it that the depth of the maze is the correct depth, not the outer edge. So the easiest way to do this is to reorder the layers within this file. Now you have to imagine, although everything looks flat, they are essentially stacked up on top of each other. And if we reorder that stack, it will change the cutting order. So I'm going to right click on the maze and go send to back. Now as you can see, it's changed the order and that the outside profile now is more predominant than the maze in the middle, which is exactly what we want. Now I just said about making this a little bit more complex for the user when playing with the maze. So let's add in some obstacles to make it a bit more challenging. So I'm going to zoom in slightly. The first thing I want to do is put a few holes along the channels so the ball may fall out and stop them from completing it. Now you could do this by inserting a circle and making this a full cut through hole. So if we really shrink this down so it fits within the channel, I'll bring it up to this top right hand corner so we can see it on the visualization. And then if we take the cut depth all the way down, you'll see it puts a clean hole all the way through this. The problem is when using the circle tool to create holes, it can actually be quite a long process, because essentially what the machine does, it will take your depth per pass. So for ease, let's call it 0.5 millimeter. It will machine 0.5 millimeter out, retract the head all the way up to the safety height, all the way back down, another 0.5 millimeter, back out, back down, another 0.5 millimeter, and so on. So to actually cut a hole this method all the way through does take quite a long time. Now the bit that we're using today is a 1/8 bit, which is a 3.175 millimeter. Now the ball bearing that we're using is a 3 millimeter, so a hole the exact size of the bit that we're using should be perfect. So rather than using the circles, we'll delete that out. We're going to use the drill feature. Now I've clicked on that and it's inserted a hole straight away. If I come bring it back up to this top right hand corner, you can see there that it's punched a hole straight through the material, and this is the same diameter as the bit we're going to use. Now the advantage of using the drill feature for a hole is it will do it much faster and much more efficiently, because it doesn't keep retracting up to the safety height, so therefore it will just make the job a little bit quicker. So what I'm going to use these holes is to try and force the user to roll the ball bearing down a channel that they don't need to go down. So undo that. Alright, we're going to drag this drill bit hole down to here, and what I'm trying to do is force them into this channel that's the dead end. I'll reposition the visualization so we can see what we're doing. So I want to try and get one hole towards this bottom edge and then two holes slightly above it on either side to make it a little bit of a slalom. So I'm going to zoom in on this a little bit more so we can be more accurate with the positioning. Now drag this down and keep it as close to the edge as possible without actually touching the edge, and try and keep it as central to the channel above it. Now I'm going to press Ctrl C, Ctrl V, which is edit and copy. You can also do that from the menu up here. And it gives us another one exactly the same. Now we're going to position this to the side of it, but slightly higher. And again, touching and close to that top wall. Now I'm going to paste another one in. And again, put that on the opposite side to create that slalom that we was just talking about. Now if I rotate this around a little bit, what we can start to see is we've got that slalom going on where it's got to be pretty tight to get the ball bearing around that gap without it slipping into this extra trench here that is no use to us. So again, just making the user's life a little bit more difficult when they're playing the maze. I'm going to zoom out. I think what I'll do with that is create multiples of those around the course itself. So we're going to select all three. So we're going to copy and paste them again, Ctrl C, Ctrl V, and we've got another set. Let's move this to somewhere else in the course that gives them a similar problem, such as this little bit down here on the bottom right. I will reposition this and zoom in a bit more so we can be accurate again. I'm just going to do this as close as I can, as I say, without touching the edges of the walls themselves. There, I'm pretty happy with that. I'll move the visualization around again so you can see what we've just done. There we are. So we've put a similar scenario in where we've got this little slalom in order for the user to get around. And I'll just reproduce that again a couple of times around the course, but I'll speed this up so you don't have to go through every stage. So there we have it. We have a few horizontal ones, and I've also put a vertical one on this far left hand side. Let's add something else. How about something with a bit of texture, so it's a bit like bumps in the track, again almost to make the ball bearings skip and make their lives a bit more difficult. So I'm going to come up to this area here where the cursor is, just zoom in a bit and reposition, and we're going to add some squares at different depths, as I say, to make a bit of a texture. So I've just inserted this square. We're going to shrink this down to roughly the same width as the maze itself. And again, I'll just reposition the visualization so you can see what we're doing. As we can see there, it's causing that bit to be a bit higher than the rest of the maze. That's because it's at a different depth. Now, that's at 8.3. I'm actually going to reduce the depth of the maze itself. It's 10.4 millimeters. The ball bearing itself is only 3 millimeters, so we can probably get away with making the depth of the maze at about 6 millimeters. This also means it should cut a lot faster because we're not machining as much detail out. Now what we can see is that square is actually inset in the visualization, so we're going to come back over to that. Now the depth of the maze is 6 millimeters, so I want to make this 6.8 millimeters. So there's a little bit of depth there, but it's just going to make it a bit more difficult journey for the ball bearing to roll over. So I'm happy with that. We're going to Ctrl V, copy and paste it, and just put a couple of them in a line, as I say, just making it more difficult for the user. Put one below it and also one above it. Now just to make sure these are sitting centrally in the maze, we can select them all, align them on the vertical middle position, and that's just brought them all in centrally, and it's now sitting within that channel of the maze itself. Now similar to what I did with the holes, I'm going to zoom out. I'm going to replicate this a few times. 1, 2, 3 to highlight them. I've also right clicked and I'm going to come down to combine to make these a group, again making our life easier to reposition them. Ctrl C, Ctrl V, and let's scatter some of these around the maze itself. So there we have it. We've got a few obstacles now on the maze to make things a bit more difficult for the user, and it's all reflected from the design onto the visualization, so we can just see that extra texture that I've added in places to make it a bit of a rougher journey through the maze. Now let's take a look at this blank space that we have over here. If we were making this as a GIF for someone, it'd be an ideal place to put a bit of text in, so that's exactly what we're going to do. For now, I'm just going to type the word maze. We're going to rotate that round 90 degrees and just get it roughly in position over here. I'm going to drag this across slightly so I can see the full area. Now I want to enlarge this so it's filling the space but still leaving that little bit of gap around the edge so it's not too close to the border itself and risk ruining any of the wood on a breakout. So we'll enlarge it a little bit. Now I'll reposition the visualization so we can see what we're doing. And I also want to check the depth of this. I don't want to make it too deep, again, to save having a long machine run. So I'm going to bring that down to about 6mm again, the same as the rest of the maze. Now I want to indicate to the user where the start of the maze is. So I'm just going to bring the text tool in again, use the same font, type start, rotate it 90 degrees again, and we want to try and shrink it down to be in that top right hand corner. So we'll do so. And I also want to put a little arrow next to it just to indicate where you should be beginning. So we're going to come up, use the triangle tool, insert that quickly, again rotate it 90 degrees, bring it up to this little gap and shrink it down until it fits the space. I also want to check both the depth on those, again not make them too deep, so I'm going to bring this down to about 4mm this time. Now what we can see on the visualization is there is a lot of blobs here because the 1/8 bit is too large to do the detail within that text itself. So we're going to try and resolve that. But the problem is when we add a secondary bit into this, it's going to treat the way it does the drill holes and the outside profile a little bit differently. Now I'm warning you up front when I'm saying this so you can actually see what changes on the visualization itself. So I've zoomed out. Pay attention to the drill holes and the width of this outside border when we add a secondary bit in. So I'm going to come up and I'm going to select a 1/16 bit. Come back out. Now what we can see straight away is it's filled in the missing detail within this start word, but it's also made this outside profile much thinner and it's also made the holes much thinner as well. It's given a bit more detail to the maze, it's given them sharper corners, but it's changed the cutting parameters of our outside profile and the holes, which is not something we wanted. Now this is a downside to Easel, is that you can't always select on certain shapes what the cutting bit is. It defines the whole job as one piece. However, there are ways around this and we'll take a look at that now. Actually, before moving on and solving that, let's set our cut settings because it will make our life easier before we separate this out into different designs. So we're going to come up to cut settings and we're going to switch to manual. Now as you know, I like to be conservative with my cuts. I would rather it go slow and finish the job than go too fast and run the risk of ruining it. Now this is also oak, so we're going to take it fairly slow. We're going to do 450mm per minute, plunge rate of 220, and a depth per pass of 0.5mm. I'm using the 2000K spindle, so I'm going to leave that at 2000, essentially telling it to run at maximum speed. Now on the 1/16 bit, I'm just going to bring that down to 450mm again, 220 on the plunge, but I'm going to make the depth per pass at about 0.4, again just for safety because it is quite a thin bit and I don't want to run the risk of breaking it. Again, we'll leave it at 20,000. So we know all of our speeds and feeds are set now. Now the problem I just spoke about with it treating certain cut paths not how we want them but how Easel is interpreting it, one way around it is to separate this design out into different sections. Now to some degree we are making this more difficult because we're adding another cut path to it, but we are getting exactly what we want and it is a way of working around Easel's limited features. So we're going to come down to this bottom blue area, we're going to click on the drop down arrow and we're going to click duplicate. Now this has just literally replicated the design that we have, and what we're aiming to do, we're aiming to keep all the detail on this left hand side, but all the bits that we definitely know need to be cut out by the 1/16 bit we're going to keep on the right hand design. So we'll come over to the left hand design first, and we're going to delete off everything that we don't need, such as the outside profile and all of these drill holes, because we know they're coming out too small. Now equally on the right hand design, we're going to delete out all of the stuff that we have left in place on the first design. So we're going to delete out the maze itself, we're going to delete out the word maze and all the other bits other than the outside profile and the drill holes. And what we're also going to do on this design now is get rid of the detail bit and just leave the 1/8 bit in place. Now as we updated that, we can see this profile cut went back to the width it should be the same as the drill holes. Now arguably you could do the profile cut with the thinner bits, but I'm always concerned that with how thin those bits are, going at depths this deep, it's a bit of a risk, so I always like to make sure I'm doing a profile cut with a decent thickness bit such as a 1/8. Now the only downside to doing this is once you separate the design out, you can no longer see what they look like together, so it's one or the other. And that is exactly why we did all the designing up front and then separated everything out later. So we know everything is now designed, we know it's separated out, and what we will essentially get is 3 separate G-code files. We're going to get 2 from the first one, which will be the rough cut and then the detailed cut, and then we'll get a third one from the second file, which will be to finish off this profile cut and the drill holes. Now to clarify what I said earlier, we're just going to run the simulate on this and make sure that the profile cut is the last thing and not the drill hole. Now if we wind this back and just work through it, we can see it's cutting all the holes first. Once it's done that, it goes on to the profile cut, which is exactly what we want. So with everything done, let's go and get our G-code generated. What we should do is click on the untitled in the top left and let's give it a name. I'll call it maze, nice and simple, save changes. And actually what we also need to do is name our artboards themselves. So we're going to click on here and we're going to click rename for this. And we're going to call this maze job 1. Click rename. And then we'll come to the second board, rename this and call it something different, maze job 2. I should explain the reason we rename these is because when we're about to export the G-code, it will give them the same name if you don't separate them out. So we're going to come up to machine. Now you may notice this looks a little bit different from our last episode. Easel have updated their software, but all the settings are still available, they're just in this general settings menu now. So that opens up. We know all these settings are saved from our last tutorial. We'll leave spindle controllers automatic, default RPM at 20,000, and then we're going to click generate G-code. Once generated, we'll then click export G-code, and as we can see it's just exported as maze job 2. That's because we've done the secondary work area. So we'll come back out now, go over to the first one. We know this has a roughing and a detail bit, so we're going to go machine, general settings again, generate G-code, and then download the roughing G-code and also the detailed G-code. Now the only thing you need to remember at this point is the order that you want to machine these out. We're going to start with the maze job 1 roughing to clear a lot of material out. We're then going to move on to the detail to finish this up and bring all the detail back that was missed in the small lettering like the start. We're then going to go over to the third file, maze job 2, in order to do that profile cut and the few holes within the maze itself. So with all the G-code exported, let's move over to our machine and start to get this routed out. So for ease, I've already positioned the bit over the bottom left hand corner of the material, and we are starting with the 1/8 bit, so that is already installed. So the first thing I'm going to do within UGS is click reset 0. Now as mentioned, we are going to be using the Z probe today, so I've already got the probe module open. What I'm going to do is raise the Z axis up by about 10 millimeters. And then move it in diagonally by about 20 millimeters. We're then going to put the Z probe in place and click initiate probe. Move those out of the way and click return to 0. Then we're going to come up to open. We're going to head to the desktop. And the first one we want to load in is the job 1 roughing pass. So we're going to click on that, open it. Everything looks like we're expecting. It's going to machine the maze itself out and the word maze. And then obviously we know the detail pass will go in and do some of that finer work on the second run. So with that all done, we know everything looks good. We're going to head up and click play and start this job off. So with the first cut done, we're now going to swap the bit over for a 1/16 bit, reset the Z, and then start the second job to do all the detail work. Now when it comes to resetting the Z, I'm just going to bring this back in slightly by 10mm diagonally. Place the Z probe back in position and run it again. I just held that in place because it's balancing on the edge. I wanted to make sure it was secured as it was moving about. So we'll take that back out the way. We'll then come back over to UGS, click return to 0. We'll then come up to open, come down to the detail pass, open that. We can see it's now loading the extra information from the detail pass and finishing off all the fine cut areas. So with that in place, we'll click play and get this job started. So with the detail cut done, we're going to drop the 1/8 bit back in, reset the Z, and then finish off this job. We'll bring it back in diagonally by 10mm, the Z probe back in place, and start the Z probe off. We'll then load the final and third part of the file in, so we'll come down to maze job 2. And as we can see from this, it is just spot drilling a few holes from these thin blue lines that we can see in the visualizer, and then multiple passes to do the finishing cut. So we know everything is in place. We'll go ahead and get this final run done. So that's the job done. Let's pull the bed back, get it popped off, and see how it looks. So just a quick tip, whenever you are sanding wood, always sand with the direction of the grain. You get a much better and much cleaner finish. And one final tip, if you're struggling to get into the channels, obviously you can use a very thin piece of sandpaper to try and get in there. But you can also use something like an Allen key that is the same width as the channel. Just push it in there, move it around the maze, and it should flatten out any rough spots and start to make sure everything is level for the ball to roll around. So after a bit of machine time and a few tool changes, we've got our finalised product, and I'm really happy with the way this has come out. The cuts are nice and sharp, and it's got a bit of contrast to it because of how deep we've gone. There's no burning or lumps around the profile cut on the edge, which means that's great. We've got a good balance with the feeds and speeds. I expected some of the smaller detail in the word start to have broken off, and it hasn't. So that's probably a tribute to using a good piece of solid wood. All I really had to do was that light sanding and run the Allen key around the grooves just to clean them up a bit. One thing I should say is obviously I use a nice piece of oak. A lot of people only have softwoods. Softwoods like pine and Douglas fir and things are a bit more fibrous, so you can often find cleaning inside the grooves may be a bit more difficult. However, it's cheaper and more accessible, so if you've only got softwood, don't worry about it. You just have to spend a little bit more time getting the sandpaper in there and clearing everything up. Now technically that is the end of today's tutorial, but why should the creativity stop there? So one extra thing I've done is I continued to make a clear cover that will sit over the top of this to stop the ball bearings from falling out when we're playing with it. This was really easy to do. All I did was take that outline profile cut off the second job we did, create a third job, change the depth of cut down to 2mm, and then cut a piece of acrylic out on the 3018 probe, and it fits perfectly. But we can also go on to do a few more things. For example, you could
seal the wood itself to really make the grain pop. You could paint everything. You could put epoxy into the letters and, you know, mix colours and stuff like that. Stick around till the end of the video to see exactly what I've done with my maze and how I finished it off. Now that is everything for today's episode. As always, thank you for watching. Any comments and tips for me as well, let me know in the chat section down below. I love talking to you all. Final thanks as always goes to my patrons. Thank you for keeping the channel going. I love the support, and if you want to get involved, check out the links in the description area below. That is everything for today, and I'll see you all on the next episode.
I began by filling the word start with milliput and epoxy putty. Once that was set, I sanded it back flat. I then clear coated the whole of the maze with varnish. I've poured little ball bearings into the word maze so that it filled them up but still allowed them to rattle about. I put the clear acrylic cover on and the game was ready to go.